Alright, going back to what we were discussing in our previous video, it's important for us to learn how to derive formulas because that not all the time, all the values of the variables are provided. And at the same time, it can help us make better decisions, especially in scenarios where collisions happen. For instance, let's say if we'll be able to determine the velocity of the second object or the velocity of an object after a collision, it can give us an idea how severe the damage that a particular object or that object might experience. So if the velocity is high, possibly the damage could be high as well. So now, to start, to get the variable that we are looking for, it's important for us to know that we have to isolate that variable. Okay? So if we're looking for the velocity of the second object after the collision, we have to isolate this and make sure that m1, v1 change plus m2 are not on this side. So like for example, another example, if we are looking for the velocity of the velocity of the first car after the collision, then we make sure that this is the only variable on this side. So we have to isolate this. And this variable m1, m2, v2 change should not be on this side. But let's focus first on deriving a formula to get the velocity of the second car after the collision. So here, what we can do is first, since we have this m1, v2, v1 change, we can transpose this on the other side. So we have here the initial momentum or the total momentum before the collision. I will just rewrite that m1 v1 plus m2 v2, sorry, okay, m2 v2, that is the total momentum before the collision. We transpose this minus m1 v1 change, and that is actually that the momentum of the first car after the collision. Okay? So, now, the only variable on this side that should not be on this side is the m sub 2 or the mass of the second car or object. So, since this variable is inversely proportional to the variable that we are looking for, we can make this variable be a denominator on the other side. So, m2 is equal to v2 change, or the velocity of the second car after the collision. So, we have successfully isolated the variable that we are looking for. But we can simplify this. So, m1 v1 plus m2 v2, that is the variable p sub I, or the total momentum before the collision. And then this one minus m1 v1 change, that is the momentum of the first car after the collision. Then divided by m2 is equal to our variable that we are looking for. Okay? That's how it works. Now, it's your turn. I want you to try this one. The variable that we are looking for is the velocity of the first car after the collision. So, you can pause this video and then write your answer in your notebook. Let's see if your answer is correct. So again, we need to isolate this variable on this side. So I will just rewrite the these variables, and they are representing the initial or the total momentum before the collision, but I'll just express them in complete form. So m1 v1 plus m2 v2, then here we have to remove this on this side. What we can do is transpose them on the other side. So since the sign here is positive, then on the other side it will be negative. M2, sorry, M2 V2 change. And actually, that is the total the momentum, not the total, the momentum of the second car after the collision. Okay? Now, we have remaining variable that has not been removed in this side or on this side. So, again, since the mass of the first object is inversely proportional to the velocity of the first car after the collision, then we can again make this variable be a denominator on the other side, m1. So this time, we have successfully isolated again the variable that we are looking for. Okay? And then again, to simplify this equation, m1 v1 plus m2 v2, that is represented or can be represented by this variable p sub I. Okay? Still, that is the total momentum before the collision. Then minus the momentum of the second car after the collision. So, P2 change. Then divided by the mass of the first car equals this variable, the velocity of the first car after the collision. Okay? So, sorry. That is the equation. Okay? So, that's it. Hopefully, you'll be able to apply this as you solve a particular problem involving conservation of momentum. Thank you.